So, welcome everyone in the room at IASSIST in Philadelphia and online. I'm Simon Hodson, Executive Director of CoData, which is the Committee on Data of the International Science Council. I'll be introducing this session and then sharing us through the speakers. This session is entitled Advancing Cross-Domain Data Integration for Global Development, Learnings from the World Fair Project. And I will start with an introduction of what the World Fair Project is, what we're trying to achieve, why it's relevant to IASSIST, and then we'll hear from three of the case studies or work packages in that project. And in my presentation, I'll explain a little bit more about what those are. But just to introduce everyone, we've got Steve McEachen, who's the director of the Australian Data Archive, and he'll talk about Work Package 6, which is integrating data from social surveys in Australia and in Europe. We've got Ran Lee, who's a local at Drexel and is representing the Salobal project, which is urban health in Latin America. And he is representing Work Package 8, which is looking at what Salobal did and can do to combine data and to harmonize data in studies of urban health across Latin America and ultimately to make their data more fair. And then finally, Arifan Gregory, who's there in the room with you along with Ran, will talk first about World Fair Work Package 7, which is about the Inspire project, about public health data and integrating public health data. And then he will introduce a thing called the Cross-Domain Interoperability Framework, which is one of the key outputs from the World Fair project. So that's the menu. I will start by introducing World Fair and giving some of the background, and I hope making clear why we think this is important to the IASSIST community and audience. So, World Fair, the full title is Global Cooperation on Fair Data Policy and Practice. It is a 2-year European Commission funded project, and we're exactly halfway through. One of the really interesting things, I think, about World Fair is that the terms of funding explicitly allowed us to fund partners from outside the European Union. So we have partners in a range of both European and countries in Europe and throughout the world. So 2 partners in Australia, partner in Brazil, partner in Kenya, in New Zealand, 3 in the US. And I think that was a very wise and far-sighted decision on the part of the Commission to have this project which was genuinely global. And the reason for that is that research disciplines, research practices are global. The things that we need to make data fair rely upon global and international decisions within particular research disciplines. And it's important if we want to encourage fair, and if we want to improve fair policy and practice, which is the objective, as you can see from the title of World Fair, that we engage with international research communities and with authoritative entities. Certain organizations which have an explicit or implicit role to represent a particular research discipline and have significant influence in the decisions that are made around metadata and around standards. And so we have a number of those organizations directly involved in the project, some of which are listed on the slide. It's also an important partnership between CoData and the Research Data Alliance, and it builds on some work that CoData has been doing for a few years, which I'll mention briefly. This is the list of partners. I won't go through them all. Please look at the slides, but it's a very strong consortium, and it's genuinely global in scope. In World Fair, in terms of the conception of the project and in terms of the objectives that we're trying to achieve, we see ourselves responding to recommendation 4 of the European Commission's report, Turning Fair into Reality. That report, or that recommendation in that report, underlined the importance of interoperability frameworks and argued that research communities need to be supported to develop interoperability frameworks that define their practice for data sharing, data formats, metadata standards, tools, and infrastructure, et cetera, et cetera. So it's important to give that authority and to enable communities to do that work and to make those decisions. But also, if we want to support and encourage interdisciplinary research, then those frameworks, those interoperability frameworks, should be articulated in common ways and adopt global standards where relevant. And those two parts of that recommendation, I think, are things that we're really focusing on and trying to address in the World Fair project. A lot of work. Fair has become a buzzword, and there's a lot of work around fair. You can scarcely get one of these e-infrastructure projects funded in Europe now if it doesn't have fair in the title. That's actually a good thing. But a lot of work is going on around findability. A lot less really serious work is going on around the I and the R, interoperability and reusability. And we're determined in World Fair to really try and address that. As I said, this builds on some work that CoData has been doing for a little while. As I mentioned in the introduction, we're the Committee on Data of the International Science Council. And in 2017, as two organizations came together to form the International Science Council, what used to be called ICSU, the International Council of Scientific Unions, which was for the natural sciences and the earth sciences and the life sciences, and the International Social Science Council, they agreed to merge, and that agreement was already established by 2017, though the merger happened in 2018. In that time, the authorities in the new International Science Council were conscious of the need to address the challenges of interdisciplinary research and wanted activities that demonstrated how we could support interdisciplinary research that combined natural sciences, earth sciences, and social sciences. So I think that's relevant to the IASSIST participants. Also, the International Science Council and its predecessors are sponsors of global research programs, things like Future Earth, integrated research on disaster risk, urban health and well-being, and a host of other global coordinating activities for particular areas of research, all of which address grand challenge research areas, all of which are fundamentally interdisciplinary. And to support those activities, we need to be able to combine data from different sources and from different disciplines. And that's what we were tasked to start exploring in 2017. And through a series of workshops, collaboration with DDI, we laid the groundwork essentially for what became World Fair. So we held two workshops in 2017 that led directly to a very close collaboration with DDI and members of the DDI community on a series of dark store workshops, a considerable interest and I think a very useful support from CoData for the DDI's cross-domain integration specification, which has now been submitted to the DDI's technical committee and will become, we hope, a formal specification of DDI. In those activities, we also looked at things like fair vocabularies, and as a result of one of the dark store workshops, the Cox et al. Article on fair vocabularies came out. That led directly to a collaboration with the International Union for the Scientific Study on Population on a report which is listed there, which was chaired by Georgia Alter, and I think is an excellent contribution to how do we make the terminologies which are essential for the social sciences, in that case demography, more accessible and more machine usable as fair vocabularies. And we also do work on digital representation of units, a measure which is related to this program. Through those activities, we also started developing a set of priorities and a methodology which revolves around looking in detail at particular case studies, some of the early case studies are listed there on that slide, and that led directly to the design of the World Fair project. And here's some information about a collaboration we had with the DDI Alliance on the DDI-CDI specification and another European Commission funded report. And that report, I think, would be of interest for some of the background for DDI-CDI and what became the World Fair project. Now, World Fair itself is designed around 11 domain and cross-domain case studies, 3 of which you'll hear about today. We chose these from our existing and growing set of partners, both in the CoData community and in the RDA community. We chose quite a lot of case studies because we wanted that wide spread of information, but we clustered them in order to make the project manageable and to identify commonalities between a number of different cognate areas. So there are 3 case studies which relate to chemistry in one way or another, chemistry, nanomaterials, and geochemistry. There are 2 which relate to biodiversity, one on biodiversity led by GBIF, looking at the new GBIF data model, another on agricultural biodiversity, which is looking at pollinator data. So ocean sciences, disaster risk reduction, which are cognate to some extent, and cultural heritage. But today, as I mentioned in the introduction, we're looking at these case studies relating to social science and health. So social surveys, population health, and urban health. So each of those case studies in World Fair are doing their own work. They're looking at their own practice. They've each conducted a fair implementation profile as a way of articulating the decisions of their community around fair and a way of identifying what gaps or room there may be for improvement. And then at the center of that petal diagram, there's the activity led by CoData of engagement, synthesis, and identifying recommendations. In that activity, we've helped the case studies run their fair implementation profiles. We're looking at what's coming out of that, and we're feeding that in to what we call the cross-domain interoperability framework. So here are some of the early outputs from that synthesis activity, a report on the fair implementation profiles activity and the presentations from a workshop we held in Leiden in October 2022. And there's linked there some of the emerging description and thinking about the cross-domain interoperability framework, working documents, outputs from the workshop, and a related policy brief. Arafan will say more about the cross-domain interoperability framework later. But in essence, its idea is to make it easier for us to combine data from different sources across domains by identifying a set of functional requirements and then making recommendations about existing or candidate standards to address each of those functional requirements. And Arafan will say a lot more about that at the end. So I hope that's given a useful overview and an introduction to what the World Fair project is and is about. And I'll hand over now to Steve for the first presentation of one of those case studies. Steve, the floor is yours.
Thank you, Simon. Just a moment, I will screen share here. And can I just confirm that's coming through okay?
That is coming through, yes.
Excellent.
Not yet on slide mode, though.
Yep, I'll move to slide mode now. Yep, excellent.
Yeah.
So, yeah, thanks, Simon. I'm going to talk, I won't take too long on this, but really talk about probably the case study within the World Fair program that's closest to home for the IASSIST audience. Although I say there are a couple others certainly that are going to be very familiar as well. This is the work package 6 on social surveys. Now it's a collaboration. I'm presenting today, but it's a very close collaboration between ADA and SICT, formerly NSD. So myself and Ryan Perry at the ADA and Hilda Orton and Hannah Thomas Peterson at SICT, and a number of other colleagues as well. What we are looking to do is really explore within the social surveys domain where we can make better use of some of the harmonisation integration frameworks as well. So what do we do within the discipline, within the domain, the social science domains, and particularly the archiving area, that allows us to more effectively interoperate? Before I get into the detail, I'm just going to give a brief acknowledgement of the land. Acknowledge traditional owners of the land, seas and waters, the areas that I live, work and meet on. And tonight that's here in Canberra, Australia. And I acknowledge their continuing connection to their culture and pay my respects to their elders past, present and future. My internet connection has been a little bit patchy as well, so I'm hoping it holds up for the evening. For most of you, our groups will hopefully be familiar. ADA has been around for 40 plus years now, based at the Australian National University in Canberra, and we provide we're the National Social Science Data Archive here in Australia. We're based within the ANU at a centre called the Centre for Social Research and Methods, which has an orientation around social science methods, training, and then archiving and major data collection programs. SICT, obviously, and many of you will know them previously as NSD. SICT develops and acquires and delivers services in education and research, providing common infrastructure for education and research in Norway. And have, as of, it was, I think, January 2022, NSD merged into to become part of SICT within Norway. The reason this collaboration, is possible is that the two organisations actually do a lot of related things that provide sort of a good bounding for sort of integration and comparison. We're both involved in collaborative international social survey projects, the European Social Survey and the International Social Survey Program, for example. We both provide data archiving services. We both conduct social survey research projects, and we're also both part of the DD Alliance and involved in the development of DDI CDI. Obviously, Hilda has a very active role, as does Arafan, in that. For those who also aren't aware, we're also part of Europe. This is the Eurovision Song Contest. Australia now appears on the map in Europe, so there was an opportunity to explore that. I make that half jokingly, but the point there is actually there's a lot of cultural comparison that occurs between Australia and Europe that it often lends itself to data integration and harmonisation as well. And that was one of the incentives here, in fact, for the for looking at this and how we were able to bring that together. So what are we doing in this work package? Those comparative survey programs have led to a lot of institutions, and particularly the ANU. ANU was one of the founding members of the International Social Survey Program, and has long had a role in a lot of the international comparative surveys, to the extent that we actually in early 2020 ran an online version of the European Social Survey, which turned out to be a pretty fortunate timing from our point of view. It actually provided a bit of grounding for the broader IASSIST program to look at some of their online data collection methods in light of COVID. It literally ran in in January, February 2020, just as COVID was emerging. So what we took the opportunity to do here was actually to look at some of the practices that are occurring within the core ESS, and then within ADA, who's providing a satellite program for looking at where there might be possibilities for machine interoperability and reusability of management and technical environments for streamlining and improving the data integration process between the two countries as an exemplar for what might be possible to do more broadly. If you think about data harmonisation and data integration, a lot of the work that we do, it often moves between whether it's working over time, working over space, over geographies, or progressively working over conceptual issues. A lot of the foundation requirements actually are quite similar. So we're looking to sort of provide a sort of an example using exemplar social research and exemplar infrastructure. What could we do to start enabling better reuse and better integration across these major investments that are made? It's going to use DDI as the basis for that, as to how we could understand how multinational collections could be made interoperability and provide a set of guidelines and tools for cross-national collections into the future. So thus far, we're about, we're coming to the halfway point of the project. The first key deliverable was delivered back in January this year. The first stage of what we did was actually to look at a case study of what we already do now. And this is actually a pretty interesting exercise in looking at the operations of archives and social science archives more generally. Obviously, I'm familiar with other archives in Europe and North America as well, and some of these practices are actually fairly consistent. We have had a pretty good experience in disseminating the standardised practices that we use. And I'll reflect on that a little bit more in a moment. So the case study really talks about looking at the practices we use within SICT and ADA and makes a comparison across a number of criteria as to sort of the viability of integrating a lot of the practices and processes, as well as the technologies that we're able to use. The next stage of work that we're currently involved in is really looking at, picking up on what we do now and what is the foundation, the baseline that we have now. What can we look at to sort of improve upon that process, and particularly with a view to looking at machine actionable content in light of the FAIR principles. So guidance around and checklists for making data fair and appropriate means of assessing fairness of social survey data, and sort of embedding those in the infrastructure that we have. And then the third stage of work will be to attempt to implement pilot implementation of some of those guidelines within the next stage of ESS and the Australian replication, which is happening later this year, and a piloting of those proposed practices. So in deliverable 6.1, the first stage of work, I say there were some pretty key messages that came through here. So, as sort of that I've kind of touched upon, we actually do quite a lot of similar things from the point of view of administrative and high-level processes and business processes. There is a lot of alignment between SICT and ADA, and I think you could probably extend this to a number of the other archives as well. So this particular slide in the report itself, which you can see on the DOI below, there's a collection of all welfare outputs that's accessible through Zenodo. Really tries to summarise some of the key comparison points between the two organisations. At a high level, there's a lot of similarities, and that kind of reflects the sort of the co-evolution of those processes. But the devil is in the details here. What we can do as humans is distinct from is adapt to differences in circumstances and differences in capabilities. Machines can't do that. And that's kind of the bridge we want to make an attempt to start to move across. So if we work our way down the sort of the screen here. We have similar standards, but we're using different versions of DDI, for example. The processing software is able to talk to each other, but works across different different software technologies. We're able to use common access and authentication mechanisms. We're progressively looking at similar tools for interoperability, and we're using the same source content. So there's a good starting point. That's the result of human practices that actually sets us up for some useful comparison. But as I say, when we get into the particulars, this is where there's quite a challenge still to get through to move into machine interoperability, and I'll sort of kind of reflect on those now. The details do matter here. So what prevents greater coordination? It's really those specific differences in the implementation in software and software and systems and standards. So different processing software does mean that the code reusability is more limited, although there is the capacity to move between particularly Python and R. They're able to talk to each other increasingly so. Different versions of standards, particularly ADA uses DDI. Codebook version 2.1, which is embedded in the Dataverse platform that we use. Reusability is not built into that, particularly machine reusability. SICT uses the DDI lifecycle 3.2 and based in Collectica. That's got reusability is much more usable. So we have to think about, well, can we reuse content effectively? And the other thing we do is, even if we could use it, have we made effective use of registries more generally? So even if we had content that could be reusable, is it made accessible in such a way that would allow that to occur? So SICT has adopted Collectica as the foundation of their metadata registry, and they've been building a GraphQL front end on the front of that as well for the management and interaction with metadata. And they're starting to build that into their processing standards. So the ADA hasn't done this, although we're now, based on the experiences we've had, talking to SICT and actually a number of others in the community, we've actually starting to implement a registry-based model as well, using Collectica as well. But up until this point, we've had little capacity to reuse metadata because the infrastructure we have just doesn't have that capacity. So this is where we would like to go now in the sort of the next stages of the project itself. So where we're heading towards, and the recommendations of the report really look at, well, what would you need to put in place, and what are the recommendations for enabling that tighter machine integration to actually occur. And they really come along in three ways: aligning standards, particularly for ADA, bring an uplift in our infrastructure to support at that, and the use of the variable cascade, which is a key part of DDI CDI as well. Using the common tools, we make common use of the IASSIST base survey questionnaire. We should be able to actually reuse a lot of the code and processing code, at least at a snippet or at a template level. Particularly code libraries should be able to be made accessible, and we're starting to talk about that. And then using the registries that exist to actually make better use of the metadata that already exists. It should be the case that ADA can actually, and we're going to trial this out, can point to the SICT registry and draw down reusable metadata from that registry rather than embedding and creating and producing our own. So how do we actually start leveraging those available registries and reusable content more effectively? So that's fundamentally where we're going at this point in our project. So deliverable 6.2 is really starting to explore that. It's the next phase of work that we're doing. So how do we look at that standards alignment? What are those common tools that we're actually looking to develop? Say, and particularly around some of those common interfaces and the shared processing, and increasingly how are we going to include in some of the work that we're doing the registry services that that would allow this to this reusability to occur. One of the points just on the is how to ensure that we have global uniqueness and persistence of our persisting the fine-grained metadata. But the sort of the work that's happening in the DDI Alliance right now is sort of enabling that to occur as well. So there's more to come, but as I say, within the domain of the social sciences, we're pretty optimistic about where the directions for interoperability might be heading, and I'll leave it there.
Thanks very much, Steve. I think questions will come at the end,
Yep.
but please be thinking of your questions in the room, and if you're online, please add them to the Q&A in the Zoom tool. I'll hand over to the next speaker, who is Ran Lee, who's at Drexel as part of the Salobal team, Urban Health in Latin America. And Ran is there, I think, in the room with you, though we can't see the room, but I trust he is there. Ran, over to you.
Thank you, Simon. I am sharing my screen. I don't know how to get it up there.
We're not yet seeing it on. Okay, it's coming through online now. And okay, so now we can see a bit of the room. We can see. I think he's sitting at the desk.
Yeah. So right now it's in presentation mode.
Okay.
Okay. There we go.
So
Okay.
online, we're seeing that at the top of the screen, but there's a whole load of scene sources, audio mixer, scene transitions at the bottom of the screen. But maybe this is okay for people if we can't fix that. But it means that the slides are not taking up a lot of the screens. Aha, that's perfect.
Okay. Sounds good. Thank you, Simon. So I'm going to get started. So hi, everyone. My name is Ran. I'm representing the Solar Ball project in this working package 8 for the World Fair project. Starting off with some acknowledgements, I just want to let everyone know this is a really big project. I'm just one small engineer in this. Actually, our primary speaker dropped out last minute, and now you get me. So you're going to get a very engineering-focused presentation. But I think it's also a kind of untold story in a lot of narratives. So just some big shout-outs: Solar Ball Data Methods Core, Carrie Moore, Goro Yamada, as well as all the 11 country teams that have contributed to the data, and as well as with the World Fair group that we've been working with: Simon, Arafan, Anna Ortegoza, and kind of our Solar Ball Fair renovation team, who have been helping to bring our data into a more fair state. So today's presentation will just go into an introduction of Solar Ball and really tell two stories. One is the story of the data harmonization itself, and then secondly is how we use FAIR, to implement FAIR, to make that data more reusable and interoperable in the global scale. And then lastly, just some lessons that we felt we learned and that might be useful for others. So an introduction to the Solar Ball project. So the Solar Ball project is funded by the Wellcome Trust with an aim to study how urban environment and policy impact health of cities throughout Latin America. And so this has been around for 5 years. We're in our 6th year, and we've been compiling data, harmonizing data. And the key story here is we want to do cross-country analysis, and Latin America has many, many countries. And one of the first things we had to do was to harmonize all of the data across the different censuses, health surveys, into kind of a statistically, methodologically harmonized data source where we can do this cross-country analysis. And this project is led by Drexel University's Urban Health Collaborative, but we have working groups in all 11 American countries. So let's talk about the data harmonization first. So kind of the schematic is we start with kind of individual input data, so raw data from the different countries that are kind of differently shaped. We have some from Brazil. For example, let's say this is census data from each of the countries: Brazil, Mexico, Chile, and Peru. And everyone's kind of different, and the goal of Solar Ball is to harmonize them into a similar format and standard where we can actually do these analyses that span across countries. And one of the issues this is why this slide is called pre-FAIR. We have a really big groups in, let's say, the mortality group was led by a group in Berkeley. Then we have maybe the social or economic group led by Jeff, random names, in Drexel. And then we had like the health data group led by James in Columbia. And so everybody kind of use their statistics and epidemiology expertise to harmonize these individual domains of data. But one of the things we struggled with early was no explicit structure established across the working groups. And so what ended up happening was every group produced kind of their output of this 11 countries in Latin America harmonized data, but with different data structures, different data formats, different code books, some in PDF, some in Word, and we dumped it on a server somewhere. I don't know if this is familiar to people, but this is kind of what we've been doing. And this led to a lot of problems. And we couldn't really have a good understanding of how many variables we had. This is something we couldn't really do. And people didn't really know what data we had, even internally. And then it was difficult to find when we were just organizing things like this. And secondly, access, so reusability is very human intensive, where somebody, once they did find out what data they have, they had to go through a staff who had to manually pull, merge, quality control, and then send out. And lastly, there are many things that we wanted to do, but we couldn't, which was figure out, catalog our data, see how much we have, do an inventory, automate data distribution, control access, and then build, analytic tools to utilize this data resource. And so coming in, working with Simon and Arifan, I think really gave us the impetus to think about our data and be like, yeah, we need to do something to make our data more machine actionable. Importantly, not just data, but the metadata. And so kind of we went through this renovation process of designing informatics standard, very inspired by DDI, I would say, but also inspired by just traditional relational database schemas. And then we compiled, so we did that renovation to standardize everything into this format, dumped it in a database, and we're in this process of building an interface for our project specifically, but also integrating with the larger research community by shipping it to ICPSR in the DDI format. And so I just want to give a brief demo of this portal, so this project-specific portal, to show how we kind of implemented FAIR. This works, great. Okay, so I am going to show 3 specific things. This is being released in September, and just for kind of focused on our own project audience. But one of the things in urban health is if you want to do analysis across country is how do you define a city? And that was one of the first challenges that we had to go through. Okay. So for example, this is Buenos Aires, and this is kind of how Argentina, I know none of this. I think it's Argentina. But this is how they define their administrative boundaries for the core city of Buenos Aires. But obviously you see that the urban extent is much, much more beyond this administrative boundary. And so kind of how we thought about this is, let's look at the urban extent. So we spatially mapped out, where the city expands to, and then took a look at, each country, what are the administrative units they have. And so, for example, this black boundaries are kind of Argentina's administrative units. And then we did some overlapping calculations to determine which of these administrative boundaries are the city. And so we selected those that kind of overlapped with the urban extent, and this is how we define cities. And we repeated this at the subcity level, so you can think of it in the US as maybe ZICTA level, and then we've also done at the neighborhood level. Again, it's pre-release bugs. And we repeated this throughout Latin America for 371 cities. And so that was the first step in urban health. That was the hard part, defining cities. And this isn't perfect, but this is what we did. And there are limitations. I'm not an expert, but I hope this kind of conveys our methodology a little bit. So now that we've defined cities, we went to each country basically, looked at what was data available, census data, health survey data, and really started harmonizing that. And so just some bullet points. So 150 million data points currently, 560 variables categorized into 6 domains, 35 subdomains. So 370 cities, 1,400 something subcities, and a lot of neighborhoods. So these are the really small granular neighborhoods that you'll see. And here we just have a few summaries of our domains. And this is a visualization that looks at the variables that we have. And you can see a lot of, at the variable count level, a lot of socioeconomic data here. A lot of physical and natural environment data. But when we look, so this is the distribution of the 560 variables by domain and subdomain. But when we look at actually the data points themselves, we see a very interesting balance with around half of our data is mortality and health data. And the other half is kind of physical environment and built environment. So SolarBall, I think one of the unique things we have is this balance between health data and exposure data, and we can really do these analyses of the effect of city characteristics on health outcomes. And so that hopefully captures the scope of the data. And one of the things we wanted to do was make the data available to our team, so automate data distribution to SolarBall researchers. And after harmonizing our data, we kind of built this really inspired by Amazon. So you can think of every item in this table as a variable and as different, things we can filter by. For example, whether this is just closed to SolarBall, or if it's public access, what are the domains, what are the subdomains, what geographic level is the data available, so country, city, sub-city, or neighborhood. And then our researchers can utilize this, for example, to look at life expectancy. Still pending renovation, so a lot of the metadata is very incomplete, but yeah, so general ideas here. And then within each of these, let's, for example, look at a closed. So within each of these, every variable kind of has its own page with some metadata. So title, definitions. Here are some of the metadata that we want to kind of bring up to date, and then preview the data. Since this is not public access, this isn't available, but codebook of the preview of the codebooks, and just a brief glimpse of data availability for this particular variable. And then in terms of distribution, we're working with 11 countries, people with various technical abilities, and not everyone knows how to use an API. So we wanted to kind of make this a very user-friendly process in that we can use it like Amazon. You want these variables, you add it to your cart. And then once you've had things, you can go to your cart, select like certain aspects of the data, subset countries, and you just put in your email and it'll email you kind of this merged data with metadata. Right now, data and metadata are just in .csv just because it's easier for people with various technical capabilities to work with. So that's kind of our implementation of FAIR, but I want to go back to kind of what is next. Oh, so 5 lessons. So firstly, we found applying version control was really, really useful, and being able to track specific changes in the metadata or any of the files using Git or GitHub. And we're starting to adapt some more modern storage formats for our data, such as Apache Parquet, which has metadata built into the data. And leaning a lot on open source software, so a lot of the functions we wanted, a lot of the processing we do can be automated and shared across all of our 11 country teams. So we've built some open source statistical packages. But importantly, I think, we built this website really to fulfill our project needs. We wanted a place where we can display our data and really tell the stories in our data, but the goal wasn't for long-term persistence or integration into this global, FAIR data repository archive ecosystem. And so the plan is to really use DDI and then deposit to ICPSR. And in terms of building the web interface, we use modern web development techniques, and we found it really valuable and really exciting for our team to be able to share our data in this format in a way that we can have more control. And the last thing I want to say is culture change was hard. Going from pre-FAIR to FAIR was a big struggle, and really having the support of a mature framework such as DDI, such as CODATA and World Fair, having these people really helped us to convince kind of our executive level people that this is something that we should do. And I'm glad to say that this really has fundamentally changed our organization for the better. For example, this is a schematic that we proposed for another recent really big institution level grant for the NIH, where we're really breaking down kind of when we approach large research projects, how do we think about it? We think about it in terms of data access, understanding, and then communicating. And all the lessons that we learned or we were proposing, such as putting data access and all of our analysis and processing under version control, and then being able to build custom web interfaces to communicate our findings to increase policy impact, but ultimately to integrate with the global research community through DDI and ICPSR in this larger FAIR ecosystem. So I think that's it, and happy to take any questions. And thanks again to Simon and Arifan and Anna. It's been great working with you guys.
Fantastic. Thanks very much, Ran. I'm sure from that presentation, you can see already some important connections between what Steve said about the harmonization of process and terminologies and what Ran described as well. And I think what Arifan has to say about public health and then about C. diff will bring the three presentations together. So Arifan, over to you.
Thank you, Simon. Let me get this in display mode. So I'm actually giving two presentations back to back here. The first is about Work Package 7, which is the Population Health Work Package. This is similar in some ways to what Ran was talking about, but has a pretty different angle. It's focused on an African effort called INSPIRE. Now, there are so many projects named INSPIRE. We wanted to start a project called CONSPIRE to figure out how they could all work together and identify one another. But you can tell it's a reverse engineered acronym, but it's a really, really good initiative. It's African owned and African led. So this is actually distinct a little bit from some of the efforts in Africa around data, where it seems people are coming in from developed countries and sort of getting the data and departing, which is not appreciated by the Africans, you can imagine. So this was really, it's currently led by APHRC, and the link is there. I'm not as involved with the organizational side of this project, so I'm not the person to talk to, but you can take a look at what's there. There are, I think, 30 some odd organizations in the network, if I remember right, and it covers Eastern and Southern Africa, so Tanzania, Kenya, Malawi, South Africa, that sort of part of Africa, which traditionally has been an area where there's been a lot of interest in HIV infection. And so they had established, even before HIV, what they call health and demographic surveillance sites, which are research institutes that are collecting high-value data in areas where you don't have a lot of clinics and hospitals to provide clinical data. And they sort of filled a hole in the data landscape around infectious disease, basically. Those centers have been working together for a long time through initiatives like In-Depth and laterally the Alpha Network. And INSPIRE really came out of the Alpha Network's desire to have better support for the data infrastructure and in sharing data, and so they could let the researchers focus on the research and have a dedicated group for sharing the data. What we're talking about here are longitudinal population health surveys. So this is survey collected data with an ongoing panel over time. And the different HDSS sites do this differently for their own research. But the idea is that they can harmonize that to a certain extent and collect it. INSPIRE was an attempt to take what had been a kind of informal aggregation of different data sets and turn that into something that was much more harmonized and shareable, basically. Now, to be fair to INSPIRE, the data sharing aspect of this from the technology perspective, the platform perspective, is only one of the things they do. They're also very big into capacity building, training researchers, training infrastructure staff, and working with governments in Africa as well, so policy support, and getting data coming from different sectors. So what I'll talk about today is the bit we've been focused on in Work Package 7, which is that data sharing piece. In terms of World Fair, and Simon sort of outlined the methodology that all of the work packages have been following, the first thing we did was sort of a fair implementation profile, and we've gone on to do some other activities. But the point is looking at the domain and figuring out how best to proceed with data sharing within the entire domain, not just within this community. And as you can imagine, population health is sort of a large area. What we chose to do was to use the Odyssey OMOP Common Data Model. Don't ask me to unpack that acronym. No one really wants to do that. But OMOP it's the OMOP Common Data Model is what you hear people call it. And Odyssey is the organization that produced it and a bunch of tools for sharing observational health data. And when I say that, I'm really talking about clinical data. However, we looked at that platform, and part of the data that we're working with is clinical data. And we thought that's a good platform also if we can extend it to accommodate population health surveys. That took some doing. For instance, when we started working with COVID data, the COVID classifications didn't have any of the African, or all of the African vaccines in them. There were some pretty clear gaps in the, quote, international standards for describing these kinds of observational health. You get into things like migration, which are core to demography and pretty hard to measure. And the data for doing that and the classifications for doing that simply didn't exist. So we had to make extensions within this framework, in the tools, in the standard classifications, to suit this for Inspire's purposes. But at the end of the day, we could still use the basic model, and we could still use, importantly, the tooling that they provide as open source. So that was a big part of deciding to use that domain standard as the basis of what we did. Here's how the OMOP CDM works, and it's pretty interesting. They came up with a relational table structure, and everyone agreed that they will map their data against that same relational table structure. Now, I've been a standards guy for decades. I'd never seen this kind of a brute force approach, and it works really well. It's simple, everybody knows the way it works, and when I write a query, I can make that a distributed query simply by hitting all the available databases. And I get results that are the same results because it's the same relational structure in each case. And distributed research is a big deal in this world. And there's some very, very impressive implementations in Europe and North America based on this model. It's a proven model, it works. They have a thing called the Athena repository for all of their classifications. Things like LOINC. These are very standard classifications in a lot of medical data and clinical applications. Athena is a great resource, even if you're not using Odyssey, it turns out. The way it works is they have what they call a cohort. They can't do sampling the way you would do in a social science survey because they can't control who they're measuring, really. They can just look into the pool and try to select from that pool the people who meet the criteria. So a cohort is basically the selection criteria for a target population. And sometimes they even leave that open-ended for a while, so you can get additional people joining the pool. You couldn't do that in a traditional social survey sample. They're quite similar some ways. Some ways they're very different. And that that nuance is actually pretty important. So it's a very, very interesting approach, and it's well-tooled. There are good, especially good R libraries for this, and also a lot of GUI-driven tools. And if you click on that link, you can read the Book of Odyssey, which is a great discussion on how they think about observational health research and how they've agreed to share data around it. Enough on OMOP. This is the sort of architecture, high-level slide about how Inspire works. The boxes on the left are basically the HDSS sites or ministries of health or other sources of data, clinical data, that we're bringing into the platform. And the data itself may be held in this cloud-based platform. It may be held at the local repositories for legal and reasons about the control of the data. But the hub itself gives you visibility into all of these using that OMOP model, that sort of standard table structure. And then we have these things called on-ramp services, and this is where the most of the work has gone to date. Because for the off-ramps, for serving this data to researchers, OMOP already gives you a lot of usable tools. So the focus thus far has been on providing researchers using that tool set with data they didn't formerly have access to. So clinical data around HIV and COVID, obviously, other kinds of data. The model turns out to be pretty generic. Clinical data, surveillance data, and longitudinal population health are really have been the focus up to this point. I want to dive inside one of those red boxes, though, and show you what that looks like. This is an example. The IDSR, this is a COVID survey developed by WHO that was reused in a lot of places for surveillance purposes, and that includes Eastern Africa and Southern Africa, largely. And we took the tools from the Odyssey community and combined those with other things. What you're seeing is a flow that is both a design time component. How do I take this source of data and map it into the standard concepts and structures? And you have to produce what we call an implementation guide. And that has to be tooled as an ETL process. And then you can execute that process on an ongoing basis. So you built in things like quality assurance checks. The data doesn't ultimately lose its source information. That's carried with the data into the standardized form. So you can always backtrack at least to what was the coding in the original data that was brought into the platform. It's not full provenance, but it's at least gives you that ability to backtrack a little bit. The idea, though, is that you'll be querying on the harmonized data. And I don't want to go through this process. It's pretty complicated. But you have to standardize these kinds of processes so you can really do this kind of data production on an ongoing basis. And a lot of work went into this. I should mention Jay Greenfield, among others. Some of you know Jay. And this was largely his brainchild. But what about FAIR? Because within the Odyssey community, they were already kind of doing FAIR. It isn't really fair in the way that we think of it. But if you were part of that community, you could share data with your peers. And you could do it quite effectively. There was a lot of distributed research going on, and it was an impressive model. It's what I call closed FAIR, that isn't even really a thing, but I don't know how better to describe it, because these people had figured out how to share data and they were making it work, but they weren't doing it in a way that was open to anyone outside the community. Odyssey, though, is aware that FAIR is going on. And there are other standards in that community they care about. You might be familiar with HL7 FHIR or CDISC or some of the other standards in related areas that have a lot of valuable data. Like CDISC is for a lot of clinical trials, mostly the pharmaceutical industry. And that data can be good for research, but they're doing it for reporting purposes. So the standards are sort of adjacent. HL7 FHIR is a lot of patient record data and transactional data about healthcare. So these things some of that data wants to make its way into a research frame. Odyssey is the research frame within the domain. They're sort of forging those alliances. And then they're looking at other FAIR standards, like schema.org, like DCAT. There's a desire on the part of Odyssey to become more fair, and Inspire is trying to align with it. And so, for cross-domain purposes, Odyssey really isn't fair, and that's not in scope, but for Inspire it is. And you'll see how that plays out. So, Work Package 7, we did the FIPS that Simon mentioned, which is really kind of a mini survey to do a quick assessment of what's going on in the domain, what's good, what's bad, what could be improved, and what direction are you headed? What do you think is fair within the domain? And it's an important way to start the process. It gives you a snapshot and highlights a lot of the failure points. And I think it was quite useful for us. But what came out of that was the need to align with FAIR in Odyssey, basically. We just delivered D7.1. Everything is a code in a European project. But that deliverable talks about how schema.org can be used to provide some really critical information for reuse of data both within and across the domains. And the big lesson here is that having a description of the variables and their representation and those definitional components is necessary but not sufficient. A lot of the usability and fitness for purpose of data, a lot of data quality, can only be understood in the context of the research that assembled the data and analyzed it. And that's reflected a bit in the literature, but not everything you need to know is in the article. Like, you actually have to understand what were they thinking when they designed the experiment and conducted it. And so Odyssey had a thing called a study-a-thon. This was part of Eden, which is an Odyssey-based effort within Europe. And they came up with this human-readable and machine-readable model using schema.org for describing this kind of contextual information around the OMOP CDM data that they were using in their studies and the results. And it's a nice little model. I'm not quite doing it justice, so there's more to it. But they were doing some very fair things. the way they implemented schema.org to describe this was very much in line with sort of other FAIR best practice as it's emerging. So we took this and we thought, well, that's nice. It's the right direction. So we're going to extend that into a machine actionable scenario around Inspire and see what that looks like. And it's a lot bigger. There's a lot of information there, because when you go from machine readable for serving that information to people to machine actionable, you need a lot more precision and you need a lot more stuff. And so what we did was we extended that schema.org model to include a huge amount of additional information. Purposes and methods. I'm going to talk about cohorts in a minute. The selections of cases from within the pool. What processing and analysis was performed. What were the outputs? What were the aggregate data? So the tabulations and so on, that based on that data came out the far end. Because in many cases, what gets shared is the tabulated data for reasons of confidentiality and so on. When you're dealing with policymakers, that's what they want to consume, even though they may be very interested in the source of the data in a particular WHO questionnaire or what have you. And so lots of pieces of this puzzle get used in different ways by different organizations, but you need to connect the aggregates with the methods and the processing and the raw data. If you don't have a picture of those things all taken together, you don't really understand what you're working with. And that was critical for us. Everything you need to know is in the article. That deliverable is about 40 pages long, lots of code samples, and it really shows you the goodness and the failure points of that approach. This is how these people think about data. And I think about data as hierarchical wide data sets, because I'm sort of coming out of the DDI world. But they think about a target cohort, which is a selection of the sample, if you will, the sample population. And then this is predictive analysis in this case. So you have the stratification criteria for the predictive analysis in a ring, and so you divide that target cohort, you subdivide it into areas, and then you look at the outcomes. And the outcomes tell you how to interpret the data for the purposes of the predictive analysis. I'm not an expert here. There are other kinds of analyses, like you might be looking at exposures and interventions. It's the same kind of diagram that Rand showed you, actually. This is the way these people think about data. It's a sort of population health perspective. And each individual case can be seen as a pathway somewhere through that hierarchy. But these are deeply hierarchical data sets, and the linking is super important. And you can't understand how to really use this data unless you have a picture of this kind of set of relationships within it. I'm not going to go into something that I don't know that well, but I can talk about the lessons learned at a pretty high level. Aligning with domain standards for FAIR of any kind is incredibly important, and it's a two-way street. You can take those models and use them, but if they don't meet your requirements and you have to nudge them a little bit, which almost everybody does, then it's a really good idea to engage with the organization that maintains the standards and have a two-way exchange. Odyssey is a great organization. Those people are brilliant, they're well run, they've done great work, and they're very responsive. We actually helped found an African chapter of Odyssey, and they were very welcoming to input coming from Inspire, even though population health is not really their focus. But they realized that it's a big world out there, and they can use the input, and they work with us in a very collaborative way to sort of make Odyssey better and to support what we're doing with the standard and the tools. So they're great. I think that's an important part of being FAIR. It's important also to remember that FAIR is not an implementation roadmap. You can't just implement FAINR and think somehow you can magically share data. It's a set of principles, not an implementation roadmap. And it makes me angry sometimes that people are that naive. When you're implementing things, and I'll talk about this more with CDIF, you really have to think about, in order to realize those principles, there's certain things you have to do. And that means agreeing on the actual outcomes of FAIR within the community. This is why FIPS are important. This is why doing a deeper dive into this. I think what you saw from Ran and Steve is that there really is a lot of identifying the important pieces within any domain that constitute FAIR. And that has to be an agreement within the domain. There's no other way nobody can dictate that to you in a way that will actually support real data sharing. Are you talking about machine readable? Are you talking about machine actionable? And so on. Lots of questions there. You might use standards that are generic. You might use standards that are specific to the domain. You have to think about that and make decisions on that basis, and that's important. The biggest lesson here is that the context around data is critical, especially in a cross-domain scenario. If I'm sharing observational health data with other people inside the domain, and even if they don't know the OMOP CDM model, they still understand how these experiments are constructed and basically what that data is. But when I want to share that data with somebody in a different domain who just wants the sort of mortality outcomes, they don't understand how that data was created. You have to describe it for them in a way that they can operate on it and understand at a machine level, basically, if you really want them to be able to pick that data up and run with it. And it may be that you've done things in the experiment that make the data not as useful or not useful at all to them. And it's easy to make mistakes at that level. As Steve said, the devil's in the details. So I'm now done with talking about Work Package 7. I'm now going to move off that little pedal and into the center to Work Package 2, which is where we are looking across the 11 use cases and trying to figure out how can we have FAIR that is between these domains. And so I'm going to talk about the cross-domain interoperability framework. Now, the relationship here is that each of those use cases is providing input from practical reality into an exercise that is largely talking at a kind of a best practice level, if you will. One of the things I was frustrated about with FAIR, and you've probably all heard like the Go FAIR cheerleading around FAIR. The world is convinced that FAIR is a good thing, but how is it supposed to work? I'm a technical guy, and I'm thinking this sounds great, but it sounds really hard. How are you actually planning on doing this? And the Go FAIR people, and I work with a lot of them, didn't have a clear answer. There wasn't a document they could point me to, and I felt like that was a bad oversight. And so a bunch of us have been trying to answer that question. How do you really make something at that scale that's supposed to be interoperable at a machine level work? It's a huge challenge. Part of the answer is what is going to come out as a draft from the World Fair project. And we're calling it the Cross-Domain Interoperability Framework. Essentially what it is, I mean, one way to think about it is that it's a common tongue so that different domains and infrastructures can talk to each other with an agreed set of descriptors for the metadata and data they're trying to exchange. And that's a little bit of a simplified view, but that's fundamentally what it is. I think of it more as a recommended set of practice. I am not saying best practice because it doesn't need to be best. It just needs to be good enough, which is, can we agree on a single way of doing things so that we can actually interoperate at the machine level? This isn't an academic exercise. This is not a research question. This is plumbing. This is designing plumbing. And I think a lot of the standards work that goes on is very valuable, but it's not answering the practical question of how do we tool this thing and make it work. And that relies on the standards, but it isn't itself a standard. It's an implementation of those standards. And so we have to come up with domain-agnostic standards and identify a coordinated set of those that will support the functions that are FAIR. And that's a complicated way to look at things. I want to talk a little bit more about that. But you're talking about agreed information expressed in a standard way. You're talking about APIs and services and choreographies, which is not something a lot of people in the metadata world think about, but are necessary to actually do this. And you have to do this in a way that provides benefit at every step. It has to be low barrier to entry, and people need to go progressively further along and get an increasing level of benefit from it in terms of their data reuse. So those are the criteria we're looking at. I think about it as a cookbook for implementers. What do you do if you want to make your data more discoverable? Here are the steps. Implement this here, ... and you will be more FAIR. So the output of this project is a draft of that, because it's pretty ambitious. Here's the thinking. Okay, on the left, we have all the domains and infrastructures in the world, and they have, some domains have 30 or 40 standards that are important to them. Some only have a dozen. We are talking about a lot of standards in a lot of domains, and it's a nightmare. It's unmanageable, and if we expect every domain to map the standards of every other domain to its own standards, that actually won't work in reality. It's never going to happen. A lot of people seem to assume that it will. Nonsense. In order to make that problem tractable, you have to lower the number of mappings. That's where CDIF comes in. It is that notionally, it's that lingua franca in the middle that allows people to take what they have in their domain and map once to and from a common target. 80% case maybe, if we're lucky. But basically, you should be able to share the high-value data within your domain if it's in demand in other domains, using a core set of descriptors. Now, there are things that break those rules. Things like geography, some classification, some domain-specific stuff, units of measure, or I'm more like species and chemical descriptions. That kind of stuff may not need mapping. Maybe people can all agree to a limited set of things that they can work with. But when it comes to really domain-specific conceptual stuff, you have to be able to map the ontologies and so on. Can we do that in a way that supports machine actionability in a practical sense by reducing the number of red arrows? The way we're organizing this work within World Fair, we have the case studies, and then we've convened a sort of working group. It's about 30 people split in half. So we have a number of small subgroups, 2 or 3 people, working in the areas that you see bulleted there. And we have to deliver an incredibly tight time frame. So these are mostly technical people from the standards that we're looking at, or implementers. And we have people like the guy who maintains schema.org. Like, we have access to some of the key people that we needed for this, people on the DCAT committee, people who've been on the PROV committee. And I'll show you the standards we're working with later. And so we have a working group that meets every 2 weeks with the subgroup meetings about every week or 2, sometimes more. And then we have the advisory group that is effectively a review committee for the product of the working group. We are just getting to the stage where we're producing reviewable drafts internally. So the subgroup produces a draft. It's reviewed by the working group as a whole, which is passed to the advisory group. And that's basically what will come out in the recommended draft. That's the working process here. But this is very much starting to happen. And obviously has to take into account the input from the use cases within World Fair. You can think about Fair as a set of business functions, okay? And Simon even mentioned this in the very beginning. I can say find. What does that really mean? What does access entail? From a business level, I have to negotiate access according to a bunch of criteria. There's an evaluation there and permissions and a workflow. What about assessment? FAIR doesn't mention assessment because it breaks the marketing acronym. But assessing data for fitness of purpose is an important activity, and you need the metadata to be able to do that to make it really fair. What does integration involve? Very metadata intensive work. What about recording provenance and keeping a data lineage as you work with the data and publish new data on the basis of the data that you took as inputs and integrated? How do we establish connections between the research activity around data and the business of research and policy? How do we manage the connections? How do you determine an ROI between the money you spent getting the data and doing the research and the good that came out of it? How do you measure the impact? These are all things that you could see as important for FAIR at a functional level. And people don't talk about that very much. And this isn't a hard and fast list that we've come up with, but it's a breakdown that indicates the sort of functional things we're thinking about. Ultimately, I can take those functions, and as a technologist, I can see them as interchanges between parties that are choreographies. Party A says this to Party B responds this way. Those things can be reflected in services calls. There has to be a formal exchange conducted through a known window, if you will. And those are services APIs. They do this in lots of industries. We don't think about our data this way. What we're passing back and forth is primarily metadata. You want to access my data? What are your credentials? Give me your credentials, give me your request, and I can respond yes or no, or, well, if you're willing to take this slight change, get rid of that variable, then I can give you access. I can do systems like that with the kind of variable level system that Ran was showing you. And places like UKDA, they're prototyping this. But I need to think about that as a choreographed transaction with service interfaces that serve standard metadata. They have to talk in a known format with a known payload. That's how interoperability works with technology. And you can hand wave all you want and pray the world was different, but sadly it is not. That requires a lot of agreement and a lot of standardization. The information requirements there's a lot of metadata in this picture. A lot of it's the same metadata across these functions, but there are specific differences. The level of granularity changes a lot. What you need to know about data to discover a useful data set is less than what you need to know to integrate that data set with another one, right? So, but the atomic description of data becomes more and more and more important as you get further along the sort of FAIR implementation stack. Thinking about standards, we're only talking about standards. Remember that C. diff is not a standard. It's just a recommendation of existing ones, an existing practice. When we're evaluating standards, what are the criteria? They have to function across domains. They cannot be domain-specific standards, which a lot of good ones are. They should be as easy as possible to adopt, and I'm going to talk about that more in a second. So as low as possible a barrier to entry. They should, as much as possible, build on existing technology investments and implementations. And the approach you use in building these recommendations should be practical. If it can't be done in the real world, don't talk to me about it. I don't need plumbing that doesn't work, right? And that's been a big problem with FAIR. What is an adoptable standard? I'm going to make a somewhat provocative argument. I don't think simplicity for the end user is all that important. I don't care if researchers understand how I model my metadata, because they don't do it. It's the developers and implementers and infrastructure people who have to understand the metadata models. It should be served to the researcher in a usable form. And if the benefit of adopting a standard outweighs the cost, people will do it. The cost of not having shareable data is vast, and the demand for shareable data is really high. This is a business case we can make if we can identify an implementable set of standards, even if they're more complex than your average researcher likes. And the simplicity the researcher experiences is made out of hidden complexity. It's the metadata people and the infrastructure people and the implementers who should deal with the complexity so the end users don't have to. That's what an adoptable standard is. And so I don't ever want to hear again in my life, oh, this is too complicated. I'm a researcher and I don't know what that is. Not important. By the time you see it, you'll know exactly what it is, right? And that's the thing we have to look at. Dan, are you scowling at me? You might be scowling at me.
I'm thinking of a million questions to ask you.
Okay. Very, very good, Dan. I knew this one would get you. What we do know is that the existing practice around metadata, more of the same is going to fail. That's it. We know that. With an exponential growth in the amount of data in the world, and with the demand for data and the data-hungry analysis approaches, man, we've got to figure out a better way to do this. And automation is that. That's why the emphasis on machine actionability in World Fair is there. Because if it's not machine actionable, it's not going to work. Okay, so if I take a look at some of those functional areas in implementing FAIR, what are the standards we're looking at? One of the things we'd really like to implement is the FAIR Digital Object Framework, if that specification comes to light in an implementable form. And we're looking at that pretty closely. There still is a lot of debate about what that specification should be. But basically what it is packaging for all FAIR resources on the network. And we need a packaging standard that tells me, and I'll show you an example in a second of kind of what it does. Discovery is a big deal. I have to be able to catalog and discover data. And so the standards that are really being used for that are schema.org and FAIR and DCAT today, both of which are largely based on Dublin Core at heart. So there's a lot of commonality around those standards. There are a million little metadata vocabularies in different infrastructures that are almost exactly the same. The DataCite one, the CESDA one, and people have to stop that. I don't care. They can have all the little extras they want, but everybody has to pick one core one and implement it the same way if they really expect to interoperate. And every group has to design its own 12 fields, and it's really, really counterproductive at this point. So that's the global FAIR perspective on this. So those are the ones that we're looking at because we think they're the most common and widely adopted. When it comes to access, that's harder because most people don't do machine readable or actionable things with data access. They say, oh, only people can do this. Turns out that's not completely true and that there are standards that talk about What are the policies around data protection? How can you describe the degree of control necessary for access to certain data? And we can do standard things with that. And there's been some very interesting work done in that field, even though it's not as far along as a lot of other areas. But access is part of this picture, has to be. How do you deal with assessing data and integrating data? Here we're looking at a number of different things. One of those is describing data structures, and DDI-CDI is designed to be able to do that in a flexible way across domain and infrastructure boundaries. That is what it's designed to do. And it's just been being blessed into a production standard, but we have some pretty promising implementations already. We're looking at SCOS and XCOS as very, very popular standards for describing concepts and statistical classifications in the linked data world. We're looking at OWL and a thing called triple SOM, which is a way of mapping ontologies and concept systems. People probably know about PROV. They may not know about IADOPT in RDM, coming out of RDA, or the observations and measurement standards from OGC. These are standards that talk about what cluster of information do I need to actually effectively reuse an observation. What relationships does that observation have to surrounding variables on which there are dependencies? What does that picture look like? I get your observation. What else do I need to actually use it? And so those are interesting standards that we're looking at. I don't know what will happen with those. This is not a definitive list. We're looking at a lot of other things. But this indicates the sort of standards that we consider cross-domain and fit for purpose. It would not be any use of those standards. It would be a narrow profile implemented in a certain way. Here's an example of what our, I'll give you the simplest one, base level discovery. What do you do for base level discovery? I have a script in my landing page talking about a static data set. It has some FDOF fields that tell me what are the metadata items, what are the schemas, what's the schema of the data. And then I have these core schema.org discovery fields. And I could have other schema.org stuff that's domain specific or extended. If I put that into JSON-LD according to a certain style, which is a kind of flat JSON-LD, Google Dataset Search will pick it up. Just about anybody can identify that and read it and search on it. That's the kind of agreement we need. So you're literally telling the implementer which standard to implement in what fashion to cover a very common use case. And each step in each of these functional areas will describe this kind of thing in ascending complexity and in ascending detail, and with subsequent cost and benefit. So that's the plan. The outcomes are a draft of this.
Yes. I think if we're going to fit in any questions, we're going to have to accelerate to the
This
end.
is basically my last slide, Simon.
Thanks, Harrison.
So what comes out of World Fair is a first draft of this thing. We have some workshops coming up in Dagstuhl and in Salzburg, and we will have to make some decisions about the directions of this future work. One of the big questions is, who will carry this into the future? World Fair is a project. It may get renewed. It would be good if we could find good organizational housing for that set of recommendations in the long term. So sorry I ran long, but I had to give 2 presentations. Simon, do we have time for questions now? A few.
We have there's a coffee break.
At
correct?
10:30.
This is actually the end of the session. If you need to go, we certainly can. We can go over for questions and answers.
I would really like to do that if that's okay.
Yeah, that's fine with me.
Unless people don't have any
Letting everybody
questions.
know what the deal is.
Simon, do you want to try to moderate this? Simon, can you hear us?
Yeah, we can now. Yeah.
So did we have questions in the chat that we needed to look at?
Yeah, we missed the last bit of your presentation actually. There was a crunch sound, and then we had no audio.
Can you hear me? Virtual?
Yeah, we
Simon?
can hear you now.
Okay.
Yep.
We do have 2 questions in the chat, both from Stefan Kramer. The first one is, will this cerebral, did I pronounce that correctly, data in ICPSR be globally available or only to ICPSR member institutions?
I actually don't know how ICPSR
Rand, speaking to the mic.
I actually don't know how ICPSR works. Do you know?
Kind of. That's going to depend on the conditions by which it gets archived at ICPSR. So you'd really have to talk to Michigan to figure the people at ICPSR to figure
But
that
I
out.
think our goal is to be as open as possible.
Yeah, I think it's fair to say that that's a recommendation that we've made, and that's going to be explored. But we're at an early stage in that process. But certainly, as Rand says, we would want that to be as open as possible.
All right, and the second question is for Arifan. How did you decide on the composition of the C. diff advisory group?
Well, we've been working on this in the workshops that Simon outlined for how many years now, Simon? Several. And
yeah, I mean, I suppose the first one was 2018, wasn't it? So, yeah, 5 years.
And what we're working to an incredibly tight timeline, an ambitious thing. And so there were certain critical people we needed, and we tried to select people who would help us produce an initial draft very rapidly. The challenge here is that a lot of the people involved in this work are standards people who like to work at a very deliberate pace, and this isn't the standard. And you're not going back and remodeling anything. It's really about implementing pre-existing things. So you need people who know those things and who are focused on that kind of implementation. So we tried to pick people from the community that we'd already worked with who we knew would be able to help us produce this draft. The intention is to open this up much more widely, but we need to get the ball rolling because I think this is not a normal kind of animal. It's not a new standard. It's a set of recommended guidelines in reference to other standards. And so that was a complicated selection process. Almost nobody that we asked refused to participate, although I think they knew that this was sort of a time-limited engagement, and some people were a little worried about the commitment to it. But I don't know, Simon, if you would have another comment on that.
Yeah, I'd just supplement that by saying that, yes, in the first instance, this was targeted identification of people that we knew had an understanding of what we were trying to do because of their involvement in those workshops and various other activities, because we wanted to do it quickly. We are also conscious of the need for consultation, for acceptance and ultimately adoption. And so there will be a process once there is a draft to broaden that consultation beyond the existing advisory group. Yes, we decided to do it in a layered step to be effective.
Question?
I hope that makes sense.
A couple of questions back here.
Thank you very much for these interesting presentations and for promoting the DDI within the C. diff framework. I'm thinking.
I've got a
yeah?
Helga.
Yeah?
I reckon it. Yeah. I've got a sort of a. It was sent to me sort of as a DM in the Zoom chat, but I don't think it's something that I can't. It's something that I'd like to talk about more publicly. So, Lemore, who's one of our moderators, said, "Will we be taking more use cases in the future?" Absolutely yes. So we're halfway through the World Fair project, and we are already actively having a number of conversations about sustainability and expansion. We do think that we've got an interesting and valuable approach. I'm sure it can be improved. I'm sure that there are tweaks, and we're very open to input. But at the heart, I think there's a very useful methodology there with the fits analysis, with the coordination, with the collaboration among both cognate and more distant case studies, and the work of Work Package 2 that Arifan has described and the C. diff. So we are involved in a number of conversations, and we're very open to new conversations about how can we identify new case studies, how can they be incorporated, how can we resource that. We can't just immediately add those to the existing project, but With resource and collaboration, I'm sure that we can expand that. So we're already talking about, in our jargon, about adding petals to that petal diagram, and we're very keen to have conversations about that. So Lemore, anyone else, we'd be very keen to pursue those discussions. And I know that Arafan's already been having some discussions there in Philadelphia this week about potential additional case studies.
Okay, so that was exactly to my point, that what we need is really organizational commitment, because this is good, or I'm sure it will be a good start at the level of semantic interoperability, and to promote and facilitate technical interoperability. But what we need is really for organizations to commit to it, to make it fly. But it is a very good start.
There has to be something to commit to before you can make that ask, Hilda. And nobody was answering that question, how's this going to work? So what were people committing to? They're hosing money at this abstract thing, and that's not going to produce the output. So I think it is just the start of that process, for sure. I think we had another question. Elisa, I think you were first, and then Dan following.
Actually, my question was already covered.
Okay, so just turn to Dan then. The gentleman in the baseball hat there.
Thanks. In the title of this section, this talk is cross-domain integration. And I was hoping to hear a lot more about DDI, CDI, and how it could be used to help with this whole problem. And in particular, see where problems with using that standard might arise in terms of the different issues that integration projects would unveil. Arafan, you mentioned that describing variables is a necessary condition for doing a lot of this integration. But then when you mentioned DDI, CDI, you talked about it being essentially structural and not somatic, and I don't know, that seems like short shrift to me. There's some, I'm sorry, I could go on and on, but maybe you can address some of this, and maybe some of the other people that have looked at CDI can say something about how well it works.
I should be very clear about that, Dan, because those terms get used to mean a host of evils to different people, right? There are, of course, semantics in any standard. And what DDI CDI describes about data is its structure and its packaging and the identity and the structural relationships between different expressions of the variable. So the variable cascade as we know it. How you define that variable, the concept you use, could come from any ontology whatsoever. It has to be open that way because different domains use different concepts. And they use those to define their variables as categories, et cetera, et cetera. I mean, you know the way that CDI applies roles. It takes concepts and applies them in particular roles relative to the data that they're used in conjunction with. And so when I say semantics, I mean really the domain semantics as opposed to semantics about the structure and the relationships that are reflected in those formal structures. A lot of metadata goodness is in the formal relationships of the structure. And that's what CDI describes, but it doesn't care how what concepts you apply as long as you can describe how they're being applied. I need to be able to identify what concepts you're using in your data and what I'm using in my data and how those things can be mapped. And so what CDI effectively functions as in what we've seen is glue to take a lot of other metadata formalizations and bring them together so that you can get a complete picture for the purposes of things like data integration and reuse. And so the term structure and semantics, I'm probably being fast and loose with Dan, and I accept that. And this wasn't a session about CDI. I would love to do one, you know, but I think that distinction between domain semantics, which are usually in ontologies or classifications or controlled vocabularies, and the structural commonalities that all data share, regardless of their domain, when you separate them, you can begin to use the structural description widely and then plug in the semantics appropriately and with an understanding of how that's being done. And that's something like the linked data world seem to have missed. They're good at defining ontologies. They're not good at defining the roles the ontologies play vis-a-vis the data they describe in a machine actionable way. So I think that's a lot of the value of CDI, basically. That was a long-winded answer to your question. I hope that was getting at the issue you raised. That's true.
Anything else?
Thanks. Limor Peer from Yale University. Thank you, Simon, for answering the question about other use cases. I'll just ask a quick question because I'm really taken with the point about the need to know the context.
Yes.
In order to really understand the data and be able to use it, Arfan. And it seems like you were focusing mostly with how and why the data were collected as the important context. Kind of like this input information, I think of it as like...
Yes.
And I'm wondering if it could be considered also to think about the context being the reuse, a specific reuse of the data. So I've been working for a long time on reproducibility. You know, we talk about that as a specific, and might that be a use case? In other words, situations where data requires other kinds of things like code and needs to be used in a particular way.
That's a really good question, and part of it is answered by the Odyssey platform itself, because OMOP, you've mapped everything against standard classifications, but you carry along the original codes and information about that transformation, because you can't actually understand the data without having that complete picture. So there's a huge amount of theoretical reuse going on in OMOP. The question is, how accurate is that reuse? Because everything is an approximation to be mapped into those standard classifications. And so I don't think it's I think it's a great thing to look at. The Odyssey tools support analyzing that exact thing because they give you enough of the provenance chain back to the source. But it's 50 shades of reuse, right? It's not as simple as, I'm reusing that thing. And the fact that there are standard concepts that are pretty well adopted in observational health makes that more possible than it would be, say, in social science, where everyone invents their own every time, right? I mean, so I feel like they're a little more disciplined because of the regulatory frameworks and the culture, but they do also have a basis on which you can begin to backtrack those things and get a handle on what the reuse consists of, and I think that's important. I think it's a very, very interesting thing to look at. But it's something that we've had to be careful not to lose going from the HDSS sites into the platform and from there into further uses of the data in research. And you know, the government agency may not care, but they might, right? So.
Yeah, I'm sorry, I'm going to need to cut things short because the next session needs to get set up.
Well, thanks to everybody for being here and online. Simon,
Yes, thank
Steve
you.
for being awake.
Thanks very much to everyone online and in the room. Thanks for your questions and your engagement with that, and I hope we can continue conversations.